As we have been discussing, we have a phenotype called the BOMBAY phenotype. And the BOMBAY phenotype was first reported by Bendy in 1952. That name is pronounced, or spelled rather, Bhendee. And in 1952, the location of the discovery was Bombay, India, or Bombay, India. So the phenotype results from the inheritance of a double dose of the H genes. All right. Remember, we said that in order to be O, you have to have H, a capital H, lowercase h, or capital H, capital H. That way you can have an expression of O. But in the Bombay situation, you have lowercase h and lowercase h gene being expressed. So the production of Bombay is very rare, but it does exist, and it's something that we need to be mindful of. So this phenotype, Bombay phenotype, can be represented genotypically by the lowercase h, lowercase h. As a result, the ABO genes cannot be expressed and the ABH antigen cannot be formed since there is no H made in the Bombay phenotype. So because there is no capital H, and you know that we need the ABH system to be in effect so that we can have the production of A people, B people, or O people. So the H helps us to determine what the blood group of is, and the H is the one that directs the body in producing the various antigen markers. But in relation to the Bombay individual, there is no capital H. And if there is no capital H, there can be no A, there can be no B, and the person cannot be expressing an O phenotype. It may look like O, but it is not O. And we will come to understand exactly what is happening with this phenotype. So in the Indian state of Andhra, we would realize that there is a prevalence of this phenotype. And when we say prevalence, we are talking about in comparison to the average population. So the Bombay phenotype is about 0.048%, and that there is considered a prevalence. All right. In comparison to in Europe, the Bombay phenotype is 0.0003%. So we are seeing how rare this phenotype is. I want us to wrap our minds around this whole phenomena of the Bombay phenotype. We had discussed previously that if you see something looking like, let's bring it up on the screen, O, and we have the lowercase h, this is not an O person. This is the representation of the Bombay, BOMBAY. This is the Bombay phenotype. FEPHENOTYPE. All right. and the genotype is denoted by HH. So this is the Bombay genotype. So if you see this or you see this, we are talking about the Bombay blood group. Now, in understanding the underlying molecular defect that occurs in the Bombay blood group, we have to realize that this is not a normal occurrence. And if it's not a normal occurrence, then we are going to be looking at the possibility that this could be considered a mutation. And indeed, it is a mutation. And a mutation in the FUT1 genes, which is the genes that codes for the H. FUT1, this is the H genes, and this is where we have the mutation. So the Bombay mutation occurs in the FUT1 genes. And when this mutation occurs, what happens is that there is the production of the genes being silenced, which means that this gene is now incapable of coding for the enzyme alpha 2L fructosyl transferase, which is the H transferase. All right, so we have a mutation. So we have the Bombay blood group. This is the phenotype, which equals the genotype. All right, and this occurs due to a defect in the FUT1, which is the H genes. All right, when this defect occurs, what happens is that there is the silencing of the gene. Of the gene expression. All right, and then when this happens, we realize that the H transferase is inhibited. So the enzyme that is responsible is for the H2L FUCOSYL TRANSFERASE. All right, and this is the H transferase. So this is basically an idea of the overview of what is happening. So as we proceed with our investigation on this phenomena, we need to understand that when this happens, the enzyme that normally catalyzes the transfer of the L-fructose in an alpha 1,2 linkage to the terminal on the galactose of the precursor molecule on the RBC forming the H, that there is inhibited. So the mutation, this mutation that we're talking about, the Bombay mutation, underlines this kind of expression. And even though this mutation affects the FUT1 T1 genes, the H genes, it also affects the FUT2 genes. And the FUT genes is the SE genes, which is the secretor genes, all right? And these genes code usually very similar to the alpha 2L fructosyl transferase. That when it is activated, it transfers fructose to form the H antigen in the secretion. So this genes is usually responsible for the expression of your blood group in your body fluid, like your saliva, your intestinal tract, your amniotic fluid. So this is the secretor genes that allows this to occur. All right. So the FU1 genes, FUT1 genes is silenced, and nobody likes to be silent, but this gene is silent, and this is the H genes. So if there is no H genes being expressed, then we can expect that there is going to be no A, no B, and no H antigens being observed. And then we have another challenge. The FUT genes is also inhibited, in which this genes is the secretor genes, the SE genes. And this genes is usually what allows our blood type to be detected in our body fluid. So now that we have an understanding of that phenomena, we can go a little deeper into observing some more intricacies as to this rare situation. It is rare, but it does exist. And if you're in the Indian population, then there's a probability that you may know of someone that has this phenotype. When family studies demonstrates the ABO genes is inherited in the BOMBAY phenotype, the genes are usually written like this. So you know that we have normally, so normal, we have A, we have B, and we have O people, and we have AB individuals. All right? But when the gene study for the BOMBAY, we normally write it like OHA. So that's BOMBAY A. All right? OHB. That's BOMBAY B. Or OH, and these are lowercase h's. So OHAB. So this is how it is normally represented. So since these red blood cells lack the ABH antigen, they fail to react with the antisera. The anti-A is not going to react because there are no A antigen binding sites on the red blood cell. The anti-B will not react because there are no B antigen binding sites on the red blood cell. The anti-H will not react because there is no H present because the H genes has been silenced. All right. So In RBC testing using the anti-A and the anti-B, the BOMBAY would phenotypically looks like a O person. So let us put it on it. You have anti-A, you have anti-B, and we have anti-H. All right, so let us put the group, GROUP. This is just a forward grouping, forward group. We're not going to use the AB, but let us put the AB just so that we can help someone who may need to understand it fully. Anti-AB and anti-H. So the anti-H is what we are focusing on, and then this is the phenotypic group, FE. Let's just put the blood group. Alright, so this person is O. If a person is O, you're going to expect no reaction with the A, no reaction with the B, because there's no A or B antigens. There's no A or B antigens, so there is no AB reaction either. But you're going to expect a reaction with the H, right? So this person is going to be O for the forward. For the BOMBAY, so this here is the BOMBAY. Let me circle that. So it's going to look similar to the O. So no reaction with the anti-A, no reaction with the anti-B, and there's no A nor B, so there's going to be no reaction with the AB. And for the anti-H, this gene has been silenced, so all of this silence. So it's going to look like a group O, but this is not a group O because of the anti-H inability to respond. It gives us an indication that something is wrong. And this is just in the forward grouping. So this here gives us an idea as to how we would go about investigating a discrepancy if observed. So this is just something that you need to bear in mind, so that if you ever come across it, maybe not in real life, but maybe in an examination, you'll be able to dissect to understand what is happening and how you would go about resolving this situation. So the BOMBAY serum contains anti-A, anti-B, anti-AB, and anti-H. And we're going to have to understand it. If it doesn't have the anti-H on the cell, we're going to expect it to be in the serum. If it doesn't have the anti-B, it's going to have it in the serum. If it doesn't have the anti-A on the anti-A antigens on the red blood cell, it doesn't have the B antigens on the red blood cell, it doesn't have the H antigen on the red blood cell, we're going to expect, because they're not present on the red blood cell, we're going to expect that they're going to be in circulation. And when they're in circulation, they can then be identified. So, in the serum, of the BOMBAY individual, we can find anti-A, we can find anti-B, we can find anti-H. So we need to bear this in mind, right? Unlike the anti-H found occasionally in the serum of the A1 and the A1B individuals, the BOMBAY anti-H can often be potent. And guess what? This is what is very important. This anti-H reacts strongly So this anti-H is potent. It reacts strongly at 37 degrees Celsius. It is an IgM antibody capable of binding complement. So it's capable of binding complement. So it's like complement binding potential. And if this occurs, it's going to lead to red blood cell RBC lysis. So you understand how dangerous this is. Transfusing normal group O blood with the highest level of anti-H concentration, the H antigen concentration, to a BOMBAY recipient with the H in the serum would cause immediate cell lysis. For the BOMBAY individual, the only blood group that can be transfused to this person is from another BOMBAY representative. All right, or let's call it recipient. So the ABH substances is also absent in the saliva because it messed up the FUT2 genes. So you cannot use the saliva or the body fluids to determine the exactness of the blood group. So let us go over some general characteristics again of the BOMBAY phenotype. So the BOMBAY phenotype, this is going to be important for us to note, especially if a question comes up or if we are at a reference laboratory in Mumbai, India, or in one of the areas in which there is prevalence of the BOMBAY blood group. All right. So for the BOMBAY blood group, we know that it is represented genotypically as HH lowercase. All right. So this is the genotype, GENOTYPE. And we know that there is no H antigens formed. No H antigens are formed because it silenced the FUT1 genes, which is the H genes. All right. And if there is no H antigen formed, then we know that there is no A or B antigens formed. The reason we know this is because the H genes codes for the A and the B, right? We know that phenotypically when we do the forward grouping, it looks like O, but it's not an O. All right, so it looks like O, but it's not O. In the serum, we will find whatever is not present on the antigen or the surface of the cell as antigens. We're going to find those in the serum. So we know that There's going to be anti-A. We know we're going to have anti-B. We know we're going to have anti-H. So all of these are present in the serum. All right? For this individual, even though we normally say that if you're a blood group O, then you are a universal donor, especially if you're O negative. In this situation, this is an exceptional situation. This is an exception to that rule. All right? So for the BOMBAY individual, they can only receive transfusion from an individual with the same blood group, or let us put from a BOMBAY individual, BOMBAY, or BOMBAY individual, which is denoted by OH. All right, so we have that in the back of our mind. So as we move forward, we are in a state where we can better appreciate the arrangement of this blood group. So I want you to also bear in mind some general characteristics of the BOMBAY blood group. We discussed them prior. So the general characteristics: we have the BOMBAY, B-O-M-B-A-Y, BOMBAY, and it is represented by O, capital O, and subscript, and then it is represented by the H, null, because there are no H phenotype. All right, so we know that there is absence of the H, the A, and the B antigens. So absence of the A, H, and B antigens. Hence, there is no reaction with the AB or the H lectin. All right? And if it's absent on the surface of the cell, it's going to be present in the serum. So in the serum, we're going to have anti-A, anti-H, and anti-B. Not only that, the H here is going to be very, very potent. All right? Now, the ABH does not secrete because this mutation impacts or impairs the FUT2 genes. All right? So no secretion. Is observed, and we're talking about secretion of the A, the B, and the H. All right, so you will not find this in the saliva. So when you do the saliva test, there will be no blood group determined from the saliva because the substances that are being looked at will not be observable. Very good. So we're having a field day. Now let us continue. We indicated that there is an absence of the alpha 2L fructosyl transferase, which is the H enzyme. So there's absence of the H enzymes. And if the H enzymes is absent, then we know that we won't be having any coding for the A, the B, or the H. But there is a presence of the A or B enzymes in the serum depending on the genotype. So there can be the presence of A or B enzymes in the serum based on the genotype. And this is the ABO genotype that we're talking about. All right? A recessive mode of inheritance has to be indicated. And with this recessive state, what happens is this. The individual presents with HH. So it's lowercase h, lowercase h. The red blood cell of the BOMBAY phenotype will not react with the anti-H, which is classically known as the Ulex europaeus. All right? The red blood cell of the BOMBAY phenotype are capable only, are compatible rather, only with serum from another BOMBAY individual. So if we give O to a BOMBAY, then that there is instant termination of the said individual. So we have to bear this in mind as we understand the complexities surrounding the various blood groups and the different anomalies that may be observed as we investigate rare cases that exist. And the BOMBAY is one such case. It was because of the BOMBAY blood group why I was fascinated with immunohematology. And another reason for my fascination with immunohematology was the idea of the chimera, genetic chimeras. I read about it and I just fell in love with the whole phenomenon. And from then, it led me to wrap my mind around immunohematology, blood banking, transfusion medicine, whatever you call it in your jurisdiction. And since then, I have spent over 10 years in practice of transfusion medicine. So I am excited for you on your journey as you seek to develop and understand, appreciate the concept, so that when you are deployed into the work world or while you're exercising your duty, you'll be able to make critical, logical decisions which will safeguard the safety and ensure the efficacy of the blood and blood products that are transfused. With that said, class is dismissed. Have yourself a great day.